Okay, hello students, welcome back to yet another session of atoms and molecules. And today we'll be dealing with the subtopic atoms, symbols, and valency. Okay, so first of all, let's talk about atoms. So we know these are the tiniest particles which make, a whole new element. Now, talking about symbols, symbols are something which we use to represent an element or atom of an element. Symbols are just like a nickname given to these atoms or elements so that you can use it in reactions or different ways. It is very simplified version basically. Now coming to the valency. Okay, now valency is something. What is the capacity of an atom to make bond with someone? Okay, or something. For example, maybe something can make four bonds, like carbon can make four bonds or share electrons and make four bonds. But maybe hydrogen can make only one bond. One hydrogen atom can make only one bond. So that all we'll see in this session. Coming to the atoms, what exactly atom is? Atom is the smallest teeny tiny particle, okay, of any element, and its chemical identity is same, which we have discussed, right? So if you take water from any different place, it's going to have same composition, same mass, everything would be same because atoms cannot be created or destroyed or cannot be splitted also. Now coming to the chemical symbols. So these symbols has been taken from English and Latin languages. So for hydrogen, it would be, you can consider it as a nickname, right? For example, for your friends, maybe you'll call Chotu or Golu, or maybe, Nikita would come to as Nikki, Niku, something like that, right? So similarly, elements, we came up with these nicknames or symbols so that we can represent in a reaction it very easily, and then we'll be able to solve those reactions and deal in day-to-day life simply. Okay, so hydrogen, it is H. For oxygen, it is O. For sodium, it's Na. How and why is it Na? It's coming from the Latin name, that is natrium, because a lot of elements starts from S, like sulfur, selenium, right? So it can get confusing most of the times. That's why we have taken the Latin name of sodium, that is natrium, and the symbol is represented as Na. For iron, it is Fe, coming from again a Latin name ferrum. Potassium, from the symbol is coming from calcium, K. And gold, it's Au. The Latin name is aurum. That's why. Now, why we are writing one, letter for, for the symbol of element. For somewhere we are writing two letters, two first letters, right? Why is it so? That comes in the formula, how we write the symbol. Okay, chemical symbols. So there are certain rules. The first rule would be symbols use just one or two letters. Okay, either one or two, not more than that you will see. So it is very short. Second is, it's always, the first letter is always going to be a capital. So for hydrogen, it's H, you have seen. For oxygen, it's O. For carbon, it's C. But if there is a second letter for some elements, because there are only 26 letters in English, right? Alphabet. So it can, and elements are around 118, right? So it can repeat. So for that reason, we are taking the Latin name, and also we are sometimes writing the second letter also. So second letter, whenever it's there, it will be in small letter, right? Small letter would be there, or lowercase would be there. Why so? Because I asked you one question in the last class, if you remember. I asked to tell the difference between this and this, and why is it so? Actually, this is nothing but a carbon monoxide. Carbon. Okay, you can write it as carbon and oxygen are involved here to make carbon monoxide. Here, this whole element is different. It is cobalt. Together, it is making cobalt. Now, if I'll write cobalt, this second letter of cobalt as capital, it will become again nothing but let me write here, carbon monoxide. So this can create a lot of problem for the scientist or anybody who's dealing with chemistry. So that's why we have come up with the lowercase for the second letter. I hope this is clear so far. If not, you can ask your doubts, okay, in comment section maybe, or you can directly contact me. Okay, rule number 4 is sometimes we use elements, cool Latin names for its symbol, like I have already told. For sodium, it's natrium. For potassium, it's calcium. For gold, it's aurum, like that. Okay. Now, what exactly a valency is? So far, I think it is clear to you what exactly atom is, what are the symbols, how it is coming from what are the rules, right? Now, coming to valency part. So, valency is something like holding hands. For example, let's take an example. So, you are here, your friend is here. You both have two hands, right? So, you can join your left hand with their right and this right with their left, right? But suppose one alien comes. Okay, we used to love this alien concept and everything when we were young, right? So, and it has four hands. Now its combining capacity is four and yours is two. So you have only two hands to offer to join, to play some game maybe, right? And yet he has two hands left, so he can combine that with somebody else, join with somebody else and play some game of, running or chain we used to play when we were young, something like that. So two, the combining capacity of your friend and yours is two, but for this alien, let's say alien A is having four. Okay, so it can bond with two different elements whose combining capacity is two. Understood? So what exactly valency is now? Now you will be able to understand this. So valency is like the number of hands an atom has to bond with the other atom. It's combining capacity basically. It tells how many electrons or atoms are ready to gain, lose or share. Okay. So for example, for example, oxygen is there. So the valency of oxygen, I'll tell you directly, it's 2. So it can give or share or, lose 2 electrons. Now, a combining capacity of hydrogen is 1. So oxygen will share its 1 electron with hydrogen and make bond here. But still 1 electron is left, right? Because its capacity is 2. So 1 hand is left. It is making bond with hydrogen with 1 hand. So it will take another hydrogen. Just like that alien did, right? You and your friend, it was shaking hands with both. So oxygen also can do the same thing, okay, with hydrogen. So that is how H2O will be made. So that is how your compounds are being formed on a very deeper level, you can say. So valency is all about electrons in the outermost shell. How many electrons are there? That we'll actually discuss in our, classes in depth, how electrons are there in the outer shell and everything. So just for, an overview, you can see that hydrogen is actually having, one second, this is atomic number here. And it is here, it's valency. Okay. So for hydrogen has only 1 electron in its outer shell and it can share it with any other element. Okay. Helium has, whereas 0. Lithium has 1. Carbon can make bond CH4. That's why it's CH4 compound is formed. Oxygen has 2. So H2O. So 2 hydrogen is added to oxygen like that. Chlorine has 1. Okay. That's why HCl. So these are few examples. Okay. Now, let's talk about this, okay, a little bit. So helium is stable. In its outer shell, actually, the first shell needs only 2 electrons. And 2 electrons are there and it's stable. Like, for example, you have a sofa at your house, which has space only for 2 people. Okay, so one is sitting here, another is sitting here, right? It's filled, stable. You don't need any more person in your house because you have occupancy of that much only. Or maybe let's say bed, occupancy of that much. A hotel is there and that hotel has occupancy of 2 people. A bed is there, only 2 people can go inside that, stay inside that, right? So it's now 2 people are there. It's stable. Now they cannot lose 1 electron or gain 1 electron. That means they cannot have 1 person extra or they cannot lose 1 person. If they lose, then this space will be again empty and they'll have to fill it with somebody, right? So this is why helium is stable and does not make bonds easily, but it does when you will, give a certain, kind of reaction. Okay, so valency, if we talk about hydrogen, valency 1, oxygen 2, I have already told you that's why it makes H2O. For carbon, the valency is actually 4. Okay, 4 electrons are there in its outer shell and oxygen has 2. I told you, right? How it is 4, what is the cellular structure, the structure of this, shells and everything that we'll discuss in depth. Oxygen has 2 electrons in its outer shell. Imagine this. And carbon has 2. So they will make bond together like this. But still carbon has 2 more electrons in its outer shell and it's not stable. So again, it will make bond with another oxygen which is having 2 electrons in its outer shell and the bond is completed. Okay, and that's how carbon dioxide is formed. NaCl, they both have 1 electron in its outer shell. So they make the bond like this and table salt is formed. Okay. Now this again, if you did not understand, come to me, ask me, because this topic is in like supposed to be in very depth. Again, there are like shells and everything which we will discuss in our classes. Okay. So quiz time. So the first question here would be symbol for sodium is sodium. SO. SO. Is it Na or is it Sd? You have to tell. And try telling how it is coming from also. Okay. From where it is coming from, which language, or why we are writing Na instead of S or something. Okay, I told you the answer, right? No problem. Tell me that. Okay. Now the second question here, I won't tell the answer. The valency of oxygen is 1, 2, or 3. That you know, we discussed, right? And which rule is correct for chemical symbols? First letter capital, second lowercase, both letters capital, both letters lowercase. Try solving these questions. Okay, and see you in the next session. Thank you so much for watching. Check out my Urban Pro profile if you want to, discuss any doubts or queries, or you want to have basically regular classes with me. Thank you for joining. Bye-bye. Take care.